Hi everyone, it's Sorkin. Today we have a problem when we are planning a travel 1 year in advance. And for example, let's take this scenario. We are traveling, let's say that on the 1st, 4th, 6th, 7th, 8th, and the 20th day of the year. And we need to calculate the minimum number of dollars, so minimum amount that we can pay for our travel, so minimum number. And for 1 day pass, we are paying cost 0. We are also given the costs. So for a 7 day, we are paying, for example, in this case, $7. And for the 30 day, we are paying $15. And we need to calculate what's the minimum minimum amount we can pay for our travel. So for example, let's take this case. In this case, we have for the first day, we can pay $2, right? For 1 day pass. For the next 4 days, we can pay $7 because it will cover all these days, right? It will cover 4th, 6th, 7th, and 8th. And for the last day, we can pay $2. And 2 plus 7 plus 2 gives us $11, which we are returning. So the way we are going to solve this problem, we are going to use a dynamic programming bottom-up approach. Let's take the example that we had earlier, 1, 4, 6, 7, 8, and 20. So what's the idea behind dynamic programming bottom-up approach? The idea is that we are solving a sub-problems of the problem that helps us to build up to our solution. So for example, in this case, we are creating an array with the same size as of our array, and we are also adding here 0. I'm going to explain why in a second. So it's the same size of our array, and also we are going to put here in our case 2 pointers, I and the j, right? So let's say that we are just paying for the 1 day pass, and we are, for example, for the first 1 day pass, we are paying for the first day, right? We are paying $2 for the next day. So we are adding the total amount that we are paying for our travel, right? So for the first day, we are paying $2. For the next day, we are paying also $2, right? So 2 plus 2 is $4. So, and for the next day, for the 6th, again, we are using, so we have 1 day, which is in our case $2. For the 7 days, we are paying $7. And for the 30 days, we can pay $15, right? So now we are using only 1 day pass for now. Just we are paying for $4, and here we are paying also for 1 day pass. So 4 plus 2 is 6. Here we are paying for the 7th day of the year. We are paying also for 1 day. We are buying a 1 day pass, so it's $8. And now we moved our I and the j pointer here. So the idea is, in our case, that let's solve this sub-problem, right? Let's say that for only these 4 days, can we do better than that? Can we pay for these days, right? For 1, 4, 6, 7, can we pay less than $7? Yes, we can. The way we are going to do that, our approach is we are going to move our j pointer backwards as far as we can, and let's say that as far as we can until it's, for example, first we are checking for the 15, then we are checking for the 30 days, right? So first we are going to check for the 7 day. So we are moving our j pointer until the difference of the I and the j. So basically these days I, right, minus days j. So this difference is less than or equal to 7. So it's less than or equal to 7. So for example, we can move our j until this point, right? Until the beginning of the array, right? Until we can move our j pointer here. So it means that this portion, right? This portion of the array, we can replace with the cost I with the 7 days, right? We can replace that with the cost 1, actually, in our case. We can replace with the cost 1. And now we are checking. Now we are comparing. So at each step, we are taking the minimum value of whatever the value is here dpi, right, whatever the value is here, or we are taking either 8, in our case it's 8, right, or we are taking that whatever our dpj, wherever we moved, because up to this point we have calculated our total sum, right? Now we want to replace this part with our cost 1, so with the 7 days. So now we are doing exactly that one here. So we are doing dpj, right, dpj, so this part plus this part, right, this part plus this part plus whatever the value of the cost 1, right, whatever the value of cost 1, it's our costs, right? So whatever the value is, so for example in this case this value is 0. Let me put that in another color. So this value is 8, right, this value is 8 from here, and this value is 0 plus 7, right? So yes, we can do better than that. We are replacing 8 with the 7 here, so right, we are setting 7 here. So that is our approach. So basically at each step we have 2 pointers, right, I and j. At each step we are moving our j pointer as far as we can move. For example, in the first case we are doing that for the 7 days, so we are moving until this value is less than or equal, this equation is less than or equals to 7, so we are moving our j. And in the second case we are moving our j until this equation is less than or equal to 30, and we are replacing that part of the array, right, that part of the array, whatever the cost is, either cost 1 or cost 2, plus whatever the sum is up to that. First thing to do, let's take the size of our array, let's call it n, and because we are going to use that a lot, so let's take the days length. Okay, and now let's create our array where we are going to store our total amount, dp, right, which we are going to return at the end. So what's going to be the size of it? The size of it, we are going to take int, and we are going to take that n plus 1, right, because we are also using the 0 index. So, and also at the end we are going to return dp, let's just return it right away. We are going to return whatever the last element is, whatever the value of last element is. Okay, now we can go over our array and we can populate our dp array of integers. So for that, let's start, we are going to start from the 1, right? We're going to start I is equals to 1, I is less than or equal to n, and I plus plus. So what we are going to do here, first let's add just a direct cost for one pass, right? And then we are going to see that can we improve that. So that's what exactly we are going to do here. We are adding dpi, so we are adding, so whatever the previous value is, right, whatever the previous value is, we are adding our current cost. So we are adding our cost for 1 day pass, which is 0. Okay, so now what we are going to do, we are going to check that can we replace that with the 7 or 15. So now let's check so now let's check for 7 days. So for that we are going to do int j is equals to, we are setting our j that is equals to 1, but not 1, but the not I, but the I minus 1, right, I minus 1. And now we are starting to move our j pointer as far as possible. So to do that, we are gonna move that until it's equals or more than 1, right, equals or more than 1. It's actually vice versa. And also another condition is that it should be less than, the difference should be less than 7 days. So then the I minus 1 minus days j minus 1, it should be less than 7. So we are moving as far as possible and we are decrementing our j. So at the next step, what we are going to do, we are going to then take the minimum. So now for the dpi, for each step, we are going to repeat the same. So we are going to check that, okay, what is can we replace that portion of the array? right? So minimum, we are gonna take dpi, right? The value that we have at this point, for example, in our case, it was 8, right? Or dpj. So we moved our j. Now we are taking j plus the cost that we have at 1, right? So we are trying to replace it. Whatever is the minimum, if let's say this value, right? We moved our j. So let's say that the value at 0 plus 7, if that is less than that, then we are going to set to our dpi, we are going to set this value. All right, so now exactly the same, we are gonna do for 30 days, right? So exactly the same we are gonna do for 30 days here, and it's gonna be cost of 2. Yeah, that's it. Let's run it. Okay, we forgot to add the return statement here. Also, it should be costs here. Let's run it one more time. Yeah, here we already defined j. Okay, it works as expected. Now let's calculate the time and space complexity. What's the time complexity of this solution? We are solving this problem in one pass, right? But we are moving our j pointers at each step. So, but they are constant, right? We are moving 7 at most we can move 7 and the 15. So we are not taking that into equation. So our time complexity is of n. How about the space complexity? It's defined by the size of our dp array, and in our case it's n. Let's just go over it one more time. So idea is that we are using dynamic programming bottom-up approach. So at first what we do, we are first calculating the direct cost here, right? We are calculating the direct cost, meaning that for 1 day pass. And then we are at each step, we are checking that can we do better than that. So we are moving our j pointer until it's less than, or until the difference is less than 7 days. So which means that for all days that we can include in those 7 days. And we are taking that, okay, the day, so whatever the sum was before that, right, before those 7 days, that and plus the cost 1, which means that for 7 days, is it less than the current amount that we have? If it's less than, we are updating that. Exactly the same we are doing for 15 days. Okay, I hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.